All right, everyone. A bit of an emergency at home where my toddler is sick, and so I can't be with you. Unexpected, but sorry to say, you'll have to deal with this video. One good thing is that it's going to be online, so you can watch it again if you need, which is good. We are starting a new chapter, and this thing is right here is going to be the bread and butter of everything factoring. Okay, there's such a powerful tool that we're going to learn here for a variety of reasons. Some of you might have already expected this if you have been practicing your parabolas and graphing and whatever, but it is what it is. Without further ado, let's get started. This is going to be something that's going to stay with you for a very long time. And visually speaking, let me tell you why that might be so powerful. Up until now, you've been doing a graph. You've been trying to figure out a parabola. And let's say we got a parabola like, you know what? Remember that my example with my little dragon, and there's a castle and there's you and you're trying to shoot a bow and arrow and be like, boo, whatever. And there happens to be some one-eyed monster. Okay. And that you have to hit. What if that monster wasn't there and this happens to be not medieval and it's actually like a target on the ground? What you might want to know is where the heck that is. In other words, you want to know how far away that is. In other words, you want to know what the x is when the y value hits a zero, when the height hits a zero. When the y value hits a zero, when the y value hits a zero, when the y value hits a zero. And even not in this factored form, what if I just give you a regular trinomial, simple or complex trinomial, where the y value is a zero, where the y value is a zero, where the y value is a zero, what is x? Now that might seem simple, but there's going to be a lot of cases where not just a parabola, it's the simplest case we can give you, but in grade 11, grade 12, things start to get a little wicked, and this pops out of nowhere. Just comes out and you're like, oh, wait a minute, I've done this in grade 10. I can solve this super complex situation because it just happens to present it to me as a trinomial. Okay, so long story short, we're going to figure out, hey, how do we solve for zeros, aka the x-intercepts of a triangle, of a parabola, or of a quadratic equation, if I see it as a trinomial? Okay. And to solve by factoring, y must always equal 0. Because, here the y equals a 0, what's x? Here the y equals a 0, what's x? Right? So please consider that concept. That's all we're doing for now. If you're not still understanding where the application comes from, just go through the motions. Okay? So here's the concept. If y equals a 0, what can x be? Some of you might have seen it might see it already because you're savvy with your number sense. But for those of you who are still wondering, I don't know how to do it, consider this. If you I wish I was there so I could see a show of hands, but I have a number, multiply by a number, but it's going to add to a zero, multiply to a 0. What are these numbers? Well, you might say, I don't know what any of the numbers are, but there's one thing for sure. You have to multiply and turn into 0. So if I have a 2 here, what do I have to multiply to get to 0? I hope in your head you said 0. What if I had a 3 here? What do I multiply to get a 0? I hope you said 0. If I had 100 here, what do I have to multiply to get a 0? I hope you said 0. What's the pattern? One of the two numbers have to be a 0. And it also counts. If I have a 2, but it multiplies 0, then the first number must have been a 0. If that's a 3, what do I multiply by? It's got to be a 0. If I had 100 multiplied by, it's got to be a 0. What if I had negative 1 million? Do I care? No, as long as the other one is a 0. Apply that idea here. One of these must be a 0. Check this out. So here's what I'm going to do. If, that red is a little little bit aggressive. Okay, let's pretend that x plus 7 is a 0. So I'm going to write this, okay? If, and you can copy with me, x plus 7 equals a 0, do the algebra with me. If x plus 7 equals a 0, how do I get x alone, and how do I find out what x could be? I hope you've done it. You subtract 7 from both sides. X has to be a 7. So take a look. Let me erase this because it's sort of getting in the way. Oh my gosh. Oh my goodness. All right. If x is a, guess what happens? I'm going to substitute x in. 0 equals -7 plus a 7 and -7 plus a 2. We've got 0 times -5. But do I care what that is? No, because I know it's going to equal a 0. So x equals -7 is an x-intercept. So let me put it in big letters. If x equals -7, my y value becomes a 0. It's an x-intercept. Yay. And you get that just from looking at a bracket, a binomial, and setting it to 0. At which point you should ask, what about the other one? Yeah, I know. So let me get a highlighter here and highlight that with a different color. Here we go. What if in a parallel universe, if x plus 2 equaled a 0? Well, do the algebra, subtract 2 from both sides. X is going to equal a -2. So I'm going to test it. Okay. If the x value is a -2, I'm substituting in -2 plus 7 and -2 plus 2. -2 plus 7, I'll do that for you. That's a positive 5 this time. But I multiply. This is going to be a 0. But again, I don't care what this number is because I know the other one will be a 0. Like, I don't have to even do this in my head. I just know that it's going to work. Right? So what's the other x-intercept? When x equals -2, my y value equals a 0. These two values are going to be my x-intercept. So you can say, solve the following quadratic relations. The answer would be x equals -7 and -2. That's how you would write it. But when I write that, you automatically know in your head the -7 refers to an x-intercept of -7, 0. So like somewhere here, -7, 0. And an x-intercept of -2, that would be a -2. And again, for your visual, if you see 2 dots there and I said that was a quadratic, if that was a parabola, you would probably think something like this or something like this or something like that. Okay, a parabola somewhere in that area. And that's it. That's it. Now, this is a full solution, so if it's confusing, I'm going to go faster, but if it's confusing, come back and try to apply what we did in this example. Okay? Example 2. Let's do a little bit faster. I see that my y value is a result of 2 binomials multiplying. It's factored, right? So it's super helpful to have it in factored form. This is why I kept on telling you to know your factoring cold, okay? Anytime I give you a quadratic, you gotta be able to do this if asked. Solve the following quadratic relation. Okay, so what is x when the y value is a 0? Okay, and when it says solve, I actually, I should have written solve when y equals 0. Okay, so if y is equal to a 0, what is x? I am not going to write all of this and check every single thing, but I will help you out and says if x minus 3 equals a 0, that means x must be a 3 and the x-intercept must be 3, 0. If x plus 2 was the binomial that equaled to 0, then x must be -2. If I plug in a -2, one of them would be a 0. If I plug in a x equals 3, one of them would be a 0. My other x-intercept is -2. Okay, oops. And so I could say 3, 0, 1, 2, 3, 3, 0, 1, 2, negative 2. It's going to be a parabola, one of these parabolas, right? So let's keep going. One last one. If, once again, y is equal to 0, please solve this quadratic relation. Okay? I'm not even going to write this because at a certain point, you're going to know exactly what's happening and you're going to be lazy and you'll say, oh, x minus 7, that could equal a 0 to make this entire equation equal a 0. And so, therefore, x must equal a 7, or if that binomial made it equal became a 0, then by multiplication this would all equal to 0. So x could be a 2. My x-intercepts are 7, 0 or 2, 0. Right? Or 1, 2 is my x-intercept, 3, 4, 5, 6, 7. It's going to be like that. So I don't know where the parabola direction is going, but I do know it crosses the x-intercept, x-axis at those locations. Okay, so I'm going to leave these for you. And at a certain point, some of you are like, whoa, going too fast. Let me try a more complete question by asking you to determine the 0, same thing. Oh, let's do one of these. Okay, please turn the page to question 4. It might be a little tricky, but I'll do A and B. The concept is still the same. Determine the zeros of the following quadratic relations. The zeros is another way of saying the x-intercept, or when y equals 0. Find the zeros is what they're saying. Hey, find the zeros is another way of asking the question. So let's do it. The principle does not change. We've got, when does that binomial equal 0? Or when does that binomial equal 0? Because if any one of them equals a 0, then we've got a multiplication with a 0. It's going to equal a 0. So I'm going to say, okay, if 4x minus 5 equals a 0, slightly more complicated, but this is binomial and algebra from the very beginning of the semester. I must isolate the x term. Add 5 to both sides. I must isolate the x. Divide 4 from both sides. So x could be 5 over 4. Of course, that also equals 1.25. It is a valid point on the graph. Okay, same thing here. If 2x plus 1 equals a 0, I must isolate the 2x term. Subtract 1 from both sides. I must isolate the x itself. Divide by 2 on both sides. So I have 1.25 as my x-intercept, and I have negative half as my x-intercept. I don't know where the parabola direction is, but I do know it crosses the x-axis at these 2 points. That's it. That's pretty much it. That's 90% of this lesson. Let's do it one more time. Consider this. Here, it looks like a different function or a different equation, but don't be fooled. This is the same as saying 5x plus 0 and x plus 2. It's the same thing. So what I like to do is simply, mentally speaking, I pretend in my head, or you can draw it, a bracket. This term is multiplying with this binomial. So the principle doesn't change. If 5x equals a 0, what's x got to be to make that equal 0? It's got to be a 0 because you divide both sides by 5. Here, if x plus 2 equals a 0, what's x going to be? Subtract 2 from both sides. So we've got when x equals a 0, y equals a 0. When x equals a negative 2, y equals a 0. There's my x-intercepts. Okay. I'll ask the substitute or on-call teacher to make an executive decision whether we need to pause and go back, because I have just one more thing to do and then one word problem. The one more thing that I have to do is consider, how do we get to this factored form when I give you a slightly different situation? Like here, 5b. What if I don't give it to you in factor form? Then it would be your responsibility to do so, to factor it, I mean. So let's do it. As a reminder, I have an a value of 2, a c value of 6, so multiplied, that's a 12. My b value is 7, and I must find the two mystery numbers that multiply to 12 but add to 7. This looks like it's going to be a positive 3 and a positive 4. So that 7 that we were talking about, let's break it up into the 3 and the 4. We've got 2x squared plus 3x plus 4x plus 6. And at this point in time, I'm going to say, hey, remember I told you that factoring is going to take you long? You're basically doing chapter 6, and you don't have to worry much about, learning new things per se. If you weren't being faithful to your homework in chapter 5 with factoring, then you're struggling here. So now's the time. Okay, now's the time to pay it forward. If you were very good with your practice, you ought to be breathing a sigh of relief. If you left it because you were procrastinating or it was difficult for you and you didn't get the kind of practice you needed, get to it. There's no shortcut to this. There's no shortcut to hard work. Okay? Here it is. And now that I solved it in factored form, guess what the x is? If 2x plus 3 equals a 0, because I've set the y to a 0, then x has to be minus 3 and then divided by a 2. If x plus 2 equals a 0, what's the x got to be? Subtract 2. There it is. All right. That's it. That's it. Just so that you have a complete picture, what's a lesson without word problems? Okay, determine the 0, same thing. Variables, it doesn't matter. It's the same idea. Again, it's the same idea. Just because it looks different, I don't want you to be caught unawares. I am simply, if you see, look at number 7. If you see that it's not a trinomial, why not turn it into a trinomial by bringing all terms to one side and setting the equation to a 0? Right? This manipulation you'll see, please try it. Okay, so same with, same with that one, same with the practice. It's all variations of the same concept. Even here, it might seem a little different, but hey, I expect you to be able to see and recognize quadratics as a difference of squares or a perfect square. You should be able to factor these no problem. Okay. Now I know I'm blitzing a little bit. It's only been like a 18-minute video so far, so let's try to do one of these word questions. The path of a stone into a ravine is modeled by the quadratic relation, blah, 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 height based off of distance. D represents the distance in meters traveled horizontally. In other words, that's the x-axis. H represents the height in meters traveling in the y-axis. Okay. Traveling vertically, so that's the y-axis, above the surface of the ravine. How far does a stone travel before it hits the water? So I know you've done this, okay? If this x-axis happens to be the water, because that makes sense, because the height is equal to a 0, right? That's the height, and that's the height equaling a 0 here. And this is the distance traveling from wherever you threw your stone. You know, you've played games before where you try to throw the stone as far as possible in like your local pond or even at a cottage or whatever. Okay, so let's figure it out. My h is equal to negative d squared plus 5d plus 84. And I want to know, when does the stone, how far does the stone travel? In other words, what is d? How far does a stone travel horizontally before it hits the water? That means h is 0. Huh, sound familiar? My y value is a 0, and I'm looking for the variable inside the equation. So I'm going to factor it. First things first, I'm going to factor out a common number because I like my my square term to be positive. So I divided out a -1, or factored out a -1, and then now I have -84 times 1 and -5 as my sum. This is going to be a little annoying. Is it a 12 and a 5? No, 12 and a 7. Yes, a -12 and a +7. It's going to add to a -5, but multiply to 84. Some of you might be thinking, are you going to get into big numbers like that? My answer is yes. At this point in time, you have enough practice with small numbers. It's about time you buck up and prepare yourself for larger numbers because the process is still the same. I will take the middle term, break it apart into the two, and if I group factor, I get d, and d minus 12, plus 7, d minus 12. You try that. I am moving a little fast here because I am a bit short on time because my child is sick. D minus 12, so I apologize. D plus 7. And there it is. So when could the rock or the stone fall in the water? D could be a +12 to make that a 0. Or D could be a -7 to make that a 0. That means the distance could be 12 meters or -7 meters? Mr. Kim, did we make a mistake? No, we didn't. 12 is up here and -7 is over here. Are we throwing the stone backwards? No. Okay, this is going to be a parabola, right? Something like this. So I drew my diagram wrong. Maybe the person is a lot taller than I thought. I don't know. But it was thrown and it lands 12 meters away from me. So in other words, we can reject this because it makes sense to throw forward and not backwards, unless you want to be technical here and just argue with me. But for the purposes of this question, I want to see if you can take a quadratic equation given in a question, understand I'm looking for x, I set the y as a 0, and you do all of this. You factor and set the y equals 0, you find your x. Okay, that's the goal today. Every question is going to give you some form of quadratic equation, and you solve for the zeros. Okay. If I went too fast, I do apologize once again, but the video will be found online, so when you can, go look at it again and practice. Okay. Have a great weekend, and I will see you when you get back. Bye.